Welcome to episode 5 of BAMTV, and this is going to be the first of a 3-part series in BAMTV where we discuss the protocol known as BACnet. So BACnet is a building automation protocol, and it's something that confuses a lot of BAS professionals. So through these next 3 BAMTV episodes, we are going to be diving into BACnet. And in this episode, we're going to explore what BACnet is. In the next episode, we're going to explore how you integrate systems via BACnet MSTP. And in the third and final episode of this series, we'll be talking through how you go and integrate systems via BACnet IP. So what is BACnet? As I mentioned, BACnet is a protocol, and a protocol, quite simply, is a set of rules for communicating between devices. So it's how you communicate, it's how you structure the communications, it's how you format the data, it's how you manage the communication process. BACnet as a protocol describes all of that. Now, BACnet, as I mentioned, consists of IP and MSTP devices. So we're going to draw out a BACnet network. We're actually going to draw out 2 BACnet networks right here. So we're going to have a router in the middle of 2 switches. Okay, and we're going to have a switch over here. And these BACnet networks, these are going to be 2 BACnet networks. We're going to call one 1000 and the other we'll call 1001. So these will be the network numbers. Don't worry if that doesn't make any sense to you. It will as we get later into this video. Coming off of these 2 switches, we will have a supervisory device, and we will have a IP controller. Okay? Off of this supervisory device, we will have, actually I want to make my triangle go that way. We will have a MSTP controller. So these will be IP connections right here. So you can see. And this will be a MSTP connection. The reason I'm laying all this out for you is because as I start to describe objects, devices, properties, services, protocols, communication formats, it helps to have a diagram. Okay, so BACnet consists of devices, and devices contain objects. So inside this IP controller, depending on its profile, more on that a little later in the lesson, we will have objects, okay? And for simplicity's sake, we're going to say we have an analog input and a binary output. These are 2 objects, okay? So these are objects right here. And then objects have properties. And so, for example, this analog input has a property called present value, and that would be the present value of the input. This binary output has a property called the priority array, and that is a very important concept in BACnet. That's how, if you have multiple things writing to an object, you use the priority array to set which one has precedence, which one's most important. Okay. Now, as I mentioned, a device consists of objects, although a device is a type of object. Now, on top of it having BACnet having devices, so this is our device, and these devices having objects, there's 54 objects in BACnet, but out of all of those, you only need to know about a dozen, maybe a dozen and a half, maybe 18. But you don't have to know all 54. Some of those are file access or life safety, access control. I was saying file access. That's actually a service category. And some of them are things that you most likely are never going to use. But the big ones, analog, binary, multi-state values, schedule, object, trend object, device object, event objects, things like that. And each object is going to have a set of properties. And there's 3 default properties, if I remember correctly. It's device type, device name, and device ID. Those are the 3 default properties for every object. And, or object ID, object type, object name. Yes. Those are the three, not device. I was thinking of device. It's actually, those are the three properties for every object. Object name, object type, object ID. All right, so you have objects, you have properties. And as I mentioned right here, you also have something else. You have a capability for these devices to communicate. And these devices communicate via something called services, okay? Now, don't worry about services. We're going to talk about a couple different types of services a little later in this video. But so far, we've got a network ID that's unique for each BACnet network. We have a device, and the device is going to have, depending on what type of physical architecture it is, it's going to have a couple different properties. All right, so there's two main types of architectures. There's IP and there's MSTP. Now there is ArcNet, there's LAN, there's Ethernet, there's peer-to-peer or point-to-point, and there is also Zigbee as architecture types for the physical communication layer of BACnet. But the primary ones we're going to run into the field are master-slave token passing and IP. IP using Ethernet at the local level network, but using IP to intercommunicate between BACnet networks across the greater BACnet inner network, as they call it. So if this device wants to communicate with this other BACnet device, then it needs to use something called a BBMD, which we're going to get to in just a second. BBMD, that's a BACnet broadcast management device, and that consists of BDTs, which if I remember correctly are broadcast definition tables, or BBMD definition tables. Don't quite memorize the acronym there, but essentially it's a list of all the BBMDs that have either been manually discovered or automatically discovered, and this tells any messages on this network how to get to other BACnet networks. So on each BACnet network, we're going to have a BBMD. And I should have drawn that box bigger, but it's okay. So what we're doing here so far, we've got one network and we've got a device. And as I mentioned, devices have three properties: ID, name, and type. Or objects have three properties: ID, name, and type, that are important. Now, from an IP perspective, we have a couple things that are really important. And don't worry, I'm going to draw services over here. But from an IP perspective, we need to know our IP address and our MAC address. These two things make up the BACnet address. Not to be confused with the device ID, which we have to have as well. And then we have to have our network number. These three properties right here of a device are very important when using BACnet, because these are going to allow our BACnet systems to, or BACnet devices to communicate to one another. So what will happen, for example, this device wants to communicate to this device over here. This is a device, by the way. This is a supervisory device. It's going to need to know the IP address and MAC address and device ID. And what's going to happen is once it knows the IP address and knows it's not on that network, it's going to communicate to the BBMD, which will do a who is service message. And that who is service message discovers that device if it doesn't already know it, creates a connection across the BACnet virtual link. I know I'm throwing a ton at you right here. And basically they communicate to one another. That's a very high-level overview of BACnet IP communications, but this is a free video, so hey. As we were talking, one more thing popped into my mind here is that with BDTs, these need to be ideally static IP addresses. And the reason why is if these IP addresses are changing, and you're using manual BDTs, meaning someone's manually putting in those IP addresses, which some manufacturers do, then if you're using dynamic host configuration protocol, that can actually cause some issues. That wasn't in the notes of what I was going to cover in this episode, but it's something I've seen a lot in the past that's caused a lot of issues, so I wanted to make sure I pointed it out. Okay, so we've got IP. Then on the other side, we have master-slave token passing. So IP wasn't adopted heavily at first, except for at the supervisory layer with BACnet, because it was viewed as more expensive back when BACnet was first created. Nowadays, we all know IP is pretty cheap. But BACnet MSTP was very cheap back then. You know, it was a self-healing network. You could have up to, depending on who you talk to, anywhere from 32 to 64 devices on a segment. And you could then use repeaters to have even more devices on a segment, because basically this would be anywhere from 2 to 4 wire connection going from a supervisory device to controller. And then you would have voltage going across these controllers. They would carry what's called a token, which a token is just a construct. It's like an Ethernet frame. Well, it's a logical construct, and the token is the form of the MSTP message container. So that message container travels along the network, and it goes in order of MAC address. That's why folks say, ideally, you want to label your MAC addresses in order, increasing from 1 to 2 to 3 to 4, all the way to 127, as long as you don't have any slave devices. Or sorry, 256 if you don't have any slave devices. Or do slave devices start at 127? I'll put that in the comments. I don't have that memorized as well. There's a lot of stuff with BACnet that I don't recommend you memorize. This is stuff you can just look up. But as I was saying, you have MAC addresses, which the MAC address on an IP device is a hexadecimal number, whereas the MAC address on a field controller is quite simply a series of dip switches that you flip to address it from 1 to 255. And that allows you to set a physical address on the controller. You still have your device ID. You still have a network number, albeit it's for the MSTP network. And you now have a baud rate, which is the speed. And this is where a lot of issues happen. A lot of issues with BACnet MSTP networks come from duplicate MAC addresses, duplicate device IDs. That's across BACnet that causes issues. And baud rates that aren't the same, speeds that aren't the same. Because if this thing's communicating the token at 36K baud and this thing's at 72K baud, then what's going on is that these two controllers are going to have data collisions. So basically the token goes from the supervisory device and it travels down in order. So if this is MAC 1, this is MAC 2. If there's any application service requests that have to go across, which we'll cover in just a second, they're attached to the token. A lot of the overhead for this right here is actually not the application, it's actually the network overhead. That's why when you want to do a lot of service requests, you ideally want to do this with IP devices and not with MSTP, because MSTP, when you get a ton of service requests going, because of the overhead of the network portion. So if you were to look at a packet or a token, it would look like this much network, and like this much would be the APDU, the Application Protocol Data Unit. This is where your service requests exist, your service requests and responses. So what's going on is these controllers right here, they have addresses. Token passes through and then returns to the supervisory device. So for example, now let's move on to services, okay? There's a lot of common services. You have the who is, I am, and the who has, I have. These are kind of two services that I bucket and I call kind of discovery services. Then you have the create and delete, if I could spell delete, object. And then you have the read and write property. And then you have the time sync. Okay, making sure you guys can see this. Guys and gals can see this here. Time sync, read and write property, create, delete object, who has I have, who is I am. So basically what's going to happen is on this network, if a BACnet device, for example, this supervisory device, wanted to go and add a new supervisory device, let's say you did a BACnet discovery. So you go on the device, you do a BACnet discovery, you're doing a who is I am, okay? So what happens is that the device will respond, I am this device, I'm of this profile, I have these objects, etc., etc., etc. Then what this supervisory device can do is it can go and use the create object. It can dynamically create if it supports that capability and add that device object and then add all of the objects underneath that device object to its database. Once it's done that, it can then go and use read and write properties. Now, that's not 100% of the time. You don't always have to create an object before you can do read and write properties. You can simply do who is and then do a write to a property once you know. But basically what's going on here, so we've done who is, I am, who has, I have. So who is, I am is for devices. Who has, I have is objects. Create, delete objects. A device is an object. A trend is an object. So whenever you're creating alarm extensions, trend extensions in a pure BACnet system, you're running this create service. Then you have read and write properties. So a read and write property, and this is a very important thing. You have what is called a server and a client. Let's add and I know this is getting really busy here, a user interface here. This user interface may say, what's the zone temperature or what's the outdoor air temperature? It sends that read property request to the server, and then the server reads the property of the controller that has that zone temp and returns it to the client. There's kind of three kinds of services that happen. There's confirmed response, they're complex, there's confirmed response simple, and then there's unconfirmed responses. So confirmed response complex is where you provide a actual value and you provide a status. It's complex. A simple confirmed request is where you just say the request ran. And then unconfirmed is where you don't even let the other requester, the client, know that the service request ran. Are you following me so far? Is this making sense? What's going on with services about how they're being used? Now you may be wondering, with all of this complexity here, how does BACnet know what's what? Well, I'm going to clean off the whiteboard and then we're going to discuss BACnet testing laboratories and certain device profiles and what that means to you as a BACnet user. All right, welcome back. So now we're going to go through the BTL or BACnet testing lab. Okay, BTL, and it's actually laboratories, but I didn't want to write out laboratories. So basically what happens is BACnet's a protocol, but in order for devices to communicate, they need to adhere to the protocol. Now, when you have large companies that are producing millions of devices, you really want to make sure that these things are all doing the same thing, that when they do a read or write property request, that it's the same request. So how they do this is they have what are called device profiles. And one of the most common ones that you'll run into is the Advanced Application Controller and the Application Specific Controller, AAC and the ASC. Now these controllers, they consist of a series of BIBs, or BACnet interoperability building blocks. Now BIBs dictate what services, what objects, what properties, etc. these devices can and do support. So for example, when a ABC Controls decides they want to certify their application controller, they have to pick which kind of profile, and these are the two more common ones, which profile they want to adhere to, and then they need to prove that they can meet the functionality required by these BACnet interoperability building blocks. Man, that's a mouthful. And once they confirm that they can meet this capability, then they release a PIC statement, or a protocol information conformance statement, which is basically saying, hey, we conform to the protocol. Here's the objects we support. Oh, by the way, if we did any proprietary objects or properties, here's what they are, etc., etc. So then as a building automation professional, whether you're in sales, engineering, or a technician, what you can do is, if you are told, hey, we're putting a BACnet IP card on this piece of equipment, you can actually go and see if it has a PIC statement. That should be kind of a red flag right there. If you're buying a bunch of rooftops and they have BACnet cards and they aren't compliant to any profile, that's kind of scary. So that would be something you would want to be concerned about, because that means that they haven't tested it for interoperability. It may not be a big deal. It may be a huge deal. Depends how risk adverse you are. So once you've confirmed that it is indeed conforming to the standard, then you're able to say, oh, these are the kind of objects. These are the kind of properties. These are the kind of services. Remember, services and properties are going to be children of objects, meaning that you have an object and it can support services and properties. And you're going to know what properties it supports, what services it supports, what objects it supports. All of this information will help you to make decisions about, can this device actually do what I need it to do? For example, if you're buying a controller and you want it to do trending and scheduling, but when you look at the PIC statement, it doesn't support those BACnet interoperability building blocks that are required for trending and are required for scheduling, then you're going to be in trouble. So that's why in your standards, in your specifications, you can actually go just to the BACnet testing laboratory site. It's really simple. And you can pull up a PIC statement and you can see if the bibs are supported, or you can do the even lazier way, which is just to specify the bibs and have the respondents prove that they actually support these interoperability blocks. This is huge. This is really important if you're going to do any form of large-scale BACnet implementation at your site. It's very important that you understand this. When I learned this, it really helped my service career. It helped my integration career because I was able to service systems better. I was able to also integrate systems better because I knew what capabilities they should and could support. So there you have it, folks. That was a decently deep overview of BACnet, and we'll use the foundations that we've learned in this course to have a discussion in the next episode about BACnet MSTP, I believe is the next episode. And we'll be talking through that, and we'll do some examples of pulling in client or master and slave devices. We'll talk about service communication. We'll talk about token structure, etc. on the next video. So thanks a ton for watching, and I look forward to seeing you all in the next video. If you've got any questions, drop them in the comment section below. Be sure to subscribe by pushing the little subscribe button over in your corner of your screen, and that way you'll be notified automatically every week when a new BAMTV episode comes out. Thanks a ton. Appreciate you being here. Take care.